Sesim geliyor mu?
Evet hocam.
Ekran peki?
O da gidiyor.
Okay. Okay, so let's continue where we left. So internet structure simply is a network of networks. We have millions of different networks, and we connect this network through the internet. So the end systems, which are the client or computers, connect to the internet through the access ISPs, Internet Service Provider. And we said that we have a residential company and university ISPs. So access ISPs in turn must be interconnected. If you connect all these together, hold on, please. Okay, so these are different access networks, as you see, and we have millions of access ISPs around the world. So the question is how to connect all of this together. So you are a computer in Istanbul and you want to connect to another computer in Brazil, South America. How to connect them together, all these ISPs. So one of way is to connect all access networks to each other, but this is not scalable because it's very complex. So another option can be to connect each access ISP to a global transit ISP in the middle, as you see. And the customer and provider in this case can have an economic agreement. Or you can divide this ISP into multiple. If one global ISP is viable business, there will be competitors. So that's why we may have a multiple ISPs, ISP A, ISP B, ISP C. And of course, we need to connect these ISPs, and which requires peering link, or another option is called Internet Exchange Point, IXP. And these ISPs are connected to the access networks through the regional networks. And sometimes these content providers such as Google, YouTube, Microsoft, Skype may have their own networks to distribute the content globally. So we said it's a network of networks, and we have a hierarchy. As you see at the bottom, we have an access ISPs. These are connected to the regional ISP, and regional ISP connect to the IXP, to the global ISP, and so on. And we said that we may have some content providers such as Google and YouTube may have their own networks to distribute their contents. This is one of the ISP Tier 1 in the US by the operator of Sprint. Okay, so after this network core, now the next question is how to measure the performance of a mobile and computer networks. So there are usually three parameters. One of them is the packet loss, packet delay, as well as the throughput. So we already discussed briefly in one of the previous slides how the loss and delay occur. And if the packet arrival, we receive a packet from client A or host B and host A, as you see, to the router. If the packet arrival rate, this is the link, is greater than the link rate, then we may have the queue. And the queue, if the buffer fills up, then we may end up with a, packet drop. if the packet is dropped, then you may lose the packet. That's where the packet loss happen. And this will result into the packet delay, of course. So we have different types of, source of packet delay. The first one is called processing delay. The other is queue delay. The third one is the transmission delay. And the fourth one is the propagation delay. Let's look at the nodal processing delay. So at the node, we check the bit errors, we determine the output link, and this processing delays is usually around millisecond. And we have the queuing delay, as we mentioned, is time to wait at the output link for the transmission. Of course, this depends on the congestion level at the router. So we have the nodal processing, we have the queuing delay, and we have the transmission delay, and finally propagation delay. So the transmission delay, as the name implies, it's the delay that takes time to send L packets over this R link, and it's calculated by L over R. And the propagation delay is depend on the distance, because it's propagated through the electromagnetic wave, which is the speed of light, and so is the distance over the speed. So the transmission delay is different than propagation delay, as you see. So there are some examples I'm skipping. You can look at this example. And of course, when it comes to the real practical delays, how the internet delay and loss look like, we use a traceroute program to measure the delay in the internet. So these are the typical log for the traceroute. Okay, the second problem is the packet loss. Because the buffer in the router has a limited memory, so that's why the packet arriving to full queue may be dropped. If it's dropped, then it may lost. And if the packet is lost, we have different mechanisms such as retransmission. So we can retransmit this the packet that is lost. Another important, maybe most important performance matrix for the computer and the mobile networks is throughput. What's the throughput? Is the number of bits that I transmit within second using 1 Hertz frequency. The number of bits that I transmit within 1 second using 1 Hertz between the sender and receiver. So we have two types of throughput. One of them is instantaneous. It's the rate given at a given point in time, specific time. And the average is, as the name implies, you take the average of throughput values over a long period of time. And we have different scenarios, which I'm skipping. And in practice, we may have some bottlenecks, as you see here, because most of the servers, they are going through this capacity, and we may end up some bottleneck problem in this case. Okay, the next topic that we're going to cover in this course is going to be protocol layers. Networks are complex, which consist of many pieces. We have a host, we have a routers, we have a switches, we have the links, we have the application, we have the protocols, we have hardware, software, and so on. So how we are going to organize all these different pieces in the network? So that's why I'm going to give an example in real life from the air travel. So assume that so if you want to fly from Istanbul Sabiha Gökçen to Ankara airport, first of all, you need to purchase a ticket. either you can do online through the mobile applications and web applications, right? This is the first step, first layer, purchasing the tickets. And after that, okay, now you purchase the ticket and now you're gonna fly next day. So you arrive to the airport. You need to check in your baggage, hand over your baggage to the air travel company. That's the second layer. And then after delivering your baggage to the air travel company, then you need to head to the gates where the airplane is located. At the gates, you board to the airplane, which is the third layer. And after that, the pilot, right, the captain is gonna, take off the airplane and take you guys to the specific routing between the Istanbul Sabiha and to Ankara through a, routing specific path to the Ankara airport. So then you landed at the Ankara airport, right? Runway, you land, and then you move to, the airplane stops at the gates, and you unload, you get off the airplane to the airport, then you go to the baggage claim to pick up your baggage, and then if you have any problem about the ticket or flight, your travel, then you call the call center, tells your complaint, right? So as you see, we have 1, 2, 3, 4, 5 in air travel. We have 5 layers because this air traveling is very complex. That's why we divide it into 5 layers. Think of that. If there is no layers, the captain is going to be responsible for selling and getting the complaint about the ticket first, and he's gonna check the baggages, and then he's gonna load you guys at the gates, board the passenger at the gates, and then he's gonna use or drive the airplanes. So one person, captain, cannot do all these complex functions, right? That's why we divide this complex operation into the pieces, into the layers. Similarly, so why we need a layering? Because we deal with the complex systems. So in order to smoothly operate this operation, so we need to split into small pieces. Similarly, we have the same problem in the networks because network is a complex operation like an air travel. So that's why we divide this model into 5 layers, starting from the application, transport, network, link, and physical layer. So at the application layer, the application runs. In the transport, we have the process data transfer using different protocols. In the network, we route, we forward the packets using the IP routing protocols. In the link layer, we transfer the data between neighboring entities such as Wi-Fi or Ethernet, and in the physical layer, we transmit the bits on the wire or the wireless link. And this is our OSI model. Actually, it consists of 7 models, including the presentation and session. So this is a typical layering application, which we call encapsulation. So at the application layer, we have a apps such as, let's say, is a mail client. You send a message, and then we frame and break this message into the packets. We add the header, it becomes segment, and then pass to the network layer. We add another header from the network, and it becomes datagram. And after datagram, we send to the link layer. These guys also add their headers and it becomes frame. And then we pass to the physical layer, and reach to the router. So the router, it removes the header and send to the switch. Any questions so far about the protocols and layers? Okay. The last topic is security. Of course, this by itself is a big topic. And in the network, we have a bad guys, we have a good guys. What we are actually trying to discuss is to solve is how bad guys can attack to our computer or mobile phones. How can we defend networks or our devices against these attacks? And the next topics is how to design architectures that are, robust to the attacks. And first of all, internet, when it's originally designed, they don't have this security in mind. So that's why this security issue comes later on. There are different types of bad guys and different methods such as, malware, spyware. So we'll discuss all this later on. We have a denial of service DOS attacks, and we have a sniffing, we have a IP spoofing attacks, and so on. So we will discuss all these different security issues as well as the attacks in one of the lectures later on throughout the semester. And the history, it usually starts this internet history around 1960s by early packet switching principles. And then in 70s, they introduced the internet networking and new and proprietary networks such as Aloha and so on, ARPANET. In 80s, we have new protocols such as TCP/IP, DNS, FTP, and so on. In 1990s, we have commercialization such as the web, World Wide Web, WW, and new apps come up at 1990s. And from after the 2000, we have, booming in these networks in terms of both computer as well as the mobile networks such as 2G, 3G, LTE, 5G now, 6G is coming. Okay, so simply we are going to discuss all these topics throughout this semester within the scope of this course. And thank you. That's my presentation for today. Any question? I guess no question, right? All right, thank you so much, and I'll see you next week. Take care. Bye.